Okay, hi, I'm Arnulf Braatz from Vector Consulting, and I'm trying to answer the question today, what a Shoemaker has to do with software quality. You might not know Vector Consulting. A few words to our consulting. It's the typical consulting services we provide in the area of safety, security, A-Spice, and those methods and tools we use there. And we're doing training in that area. So that is in a very nutshell what we as a consulting branch are doing. That also means we have something to do with the software-defined vehicle. That's the concept which is around everywhere now, right? And for sure, it's not about software quality. There are so many topics behind. So in a nutshell, software-defined vehicle means business model in essence, because we want to sell things after we have sold the car to our customers, right? There shall be a software shop, there shall be updates of software and even paid services. That is the economic idea of a software-defined vehicle. But to do this, we have to change technology. So there is a lot ongoing, let's say. So we have AI there, not the topic today. We have the vehicle OS or the software architecture base layer there. Not really a topic today. We will talk about the third topic in that technology tree, which is the software factory, which can be considered at the beginning as a highly automated tool environment where we develop and test software. Maybe even there is system engineering in there. How does it look like? So if you look into the average, let's say, in our industry, it's more a partial automation we see there. Here you see, as an example, a V-cycle-oriented set of tools, right? Starts with requirements and software architecture, goes down to some IDEs to write the code. Right side, you see all the test codes, test tools, and they are connected by direct input-outputs, because might be that one output of one tool can be read in by the next tool, or it's by file, where you have to save it somewhere. Then the next tool has to convert that file into the local format the tool can work with. So you could say that green thing is a kind of flow of materials or flow of information in a kind of factory. Then we have automation, of course. We don't want to do everything manually, then it would not be a factory, right? So we have lots of test configurations for tools. We have a lot of scripts to automate tools for instance, just start a test campaign without sitting next to the tester, just pressing a button, and then the machine is doing its own thing, right? And you wait until you get the result. Yes, this is also part of what we see today as an average, together with process description, of course, right? Still, there's a lot of manual work to be done by the engineers. And yes, of course, software quality is measured there by traditional means. So we call this thing a partial automation. It's hard to say when a partial automation turns into a software factory. It does not happen overnight, right? But yes, we see there's more potential to automate for sure. The goal you want to achieve with having a software factory, of course, it's CI/CD, that is also everywhere now, right? That is the best known and the preferred model on the software layer, how we want to work together, right? So that is for sure inside the software factory. But then there's a bit more we want to achieve because it's a business case behind. So we want to scale our factory like a real physical factory. If you have to produce 100,000 more cars in your factory, you have to set up a new production line or you have to build a new factory. But that will be a copy of the existing one. So that thing works by every kind of scale. So that is the thing we want to do with software. By whatever project is coming, we can provide our production line, if you like, to this project, and they can use the same set of tools like another project that follow the same processes and so on. So that is one thing, because we have to develop software worldwide and fast, right? So we have not time to download some tools and to install them locally on a laptop and to configure these tools based on written text. This is not scaling, right? This is more on the left side of the partial automation. Yeah, software quality is always a topic, or quality in general in a factory, right? So we want to have steady quality, which is determined by the means of a factory. So not by the means of how good the people are in shape today, right? How much fun the software developer has today. That should be minimized at least, that this has no impact on software quality. So more automation. And the whole thing is virtualized. That makes sense. The software factory for sure is not a physical factory. We can do all the things, let's say, in a cloud or in a client server environment. We don't need building for that. Let's say, okay, the computer have to reside in the building, but we don't need a production line with a physical machine. There's all software, right? So that's a goal we have, from a partial to the full automation. As a summary, finally, it's a kind of chaining, like the real factory chains machine tools together in a flow, which forms the production process. We want to chain software system development tools together, that they form the process and minimize the manual effort there. Of course, still we have to write requirements, right? Still we have to maybe do design, software design. That is not automatically done by a tool so far. We come back to that topic if we talk about AI, but that is not a natural part of a software factory, right? The automation is more on the right side of the V-cycle. Similar or kind of simple comparison between physical factory and the software factory. We use different terms, but we mean maybe the same thing. So the machine tool we see in a factory, that is a tool in the software factory. The data flow and the file system, that is the transportation of material. That's the workflow on the software factory side. So the production plan, which is there for the real factory, that turns into a set of pipelines and configurations on the software factory. And finally, we have a manufacturing process. Even that is typically a written piece, right? We have the same thing on the other side in the software factory with the development process, which follows all these known standards, right? Safety, security, ASPICE, that has to be all in there. Okay, this is so far the terms we will use now. Before we now look into a software factory, it's an example and see what it makes with software quality. A short view back to history, let's say, right? If you are comparing software development now with a shoemaker, right? Now the shoemaker comes in. Then we could picture the case that in the very early days, right, in the Stone Age, people have, with simple tools, also created something like a shoe. And we did the same things, let's say, in the 1970s with software. We had just editors, maybe with highlighting of syntax. We had some command line tools, debugger, compiler, and all these things, and we did everything more or less manually. The early days of software development. So kind of, if you compare it to the Middle Age, where the tools have been a bit more optimized for shoemaking in the shoemaker area, so also we got more tools which are more streamlined to efficient development of software. So IDEs, for instance, where you have an integration of everything in one tool, the debugger, the editor, the compiler. You have everything in one place, right? That, of course, is much more efficient than the one we did before. So if we now go back, follow the historical arrow more to the presence, then we come to something like early automation, which was also in the shoemaker area, right? So first machines came in, drilling machines. Here you see a grinding machine, which of course made the job faster. So each shoemaker now in a kind of factory could produce more shoes. There have been shelves to store all the material for the next production step. So that was the beginning of automatization, the beginning of industrialization. And so same thing happened somehow. Don't ask me for a year, right, when then that happened. The same thing happened also to software. So it's kind of what we have seen in the partial automation, right? So we have defined processes, defined locations on file systems. Yeah, still we use IDEs, but also some test tools. So it was not completely automated, but it was a clear process there. How to write the software, where to store result, what tests have to be applied, and so on. So that is a kind of early automation phase in the software area. And then we come to something we are talking about today, the software factory. So where we have more or less not only machine, but mostly machines doing the job. And we have an integrated tool set where everything is together, where we have repositories which also are doing the merging, which are taking over version management, all these things. So all these tools we are using now covering more areas of automation than in the versions we have seen before. So that is kind of what we would call a software factory, right? Looking to the future, of course, in production, they all dream from the human-less factory where just robots doing the work, right? Manufacturing cars or whatever. And even we dream that in the software development. We dream about now agents, AI agents, taking over responsibility. We just have to prompt something, and then they do the job for us. So they maybe even write requirements, not just doing the same automation steps we know from the software factory, but also writing content, writing requirements, writing test cases, even writing code, right? So yeah, that would be also a software developer-free kind of, well, however you call that software factory, right? So it's an AI-based DevOps environment. It is also a kind of vision. I wouldn't say this is already visible on the practical side. That is what we talk about and what we would like to have, at least some of us. If you are a software developer, you might not like that. But that is a part of the ideas which are around. But that is future, right? Let's go back to our software factory. Yeah, so also here you see that all the production paradigms we know from the physical factory, they apply also to software factory. But of course, the implementation is different. So now we have everything together to say, okay, how would that software factory now look like, right? So yes, first message, there is not the one and only software factory, because if you think about tools, then you know that every company using a different set of tools. So there cannot be just one factory, right? But there can be a kind of concept for that, a blueprint for that factory. So what do we need? So we need, first of all, a kind of software layer for visualization of the factory. That might be a cloud service, might be something on a server. We have to be able to distribute our factory to each engineering working place in our company. So then we have a repository on the left side. That is something like GitLab or even Subversion would work, right? Where we can store the data in a foreseen way, where some versioning is overtaken, some document management is in there. So that is our source of material we work with. And then we have also core features on the right side. This is what the factory has to provide to every kind of project. For instance, predefined pipelines for automation to ease the automation of steps. So where maybe some steps predefined already. Or management of software dependency, what I need for my software before I can release. This is also part of the core feature. In the upper part of the tool software as a service, the tool offering, there you see a bunch of tools used by the company and controlled by this factory. These tools have now, by pipelines, a kind of strict order. Who's called first, what is done with the output, who's consuming that, and so on. And that is all done in a perfect case automatedly with automated scripts. But yes, of course, in that factory, still, we have to assume we're writing requirements and we're designing software. So it's not all gone. We have not thrown every software developer out of our factory, right? Good. That's the blueprint. So again, tools might differ, right? But the concept is more or less what you see here. So what's now with our software quality, right? We want to see. Yeah, that is somewhere in here. Not really its own block. That has to be assured somehow at the tool side, right? Our process with all the software quality criteria has to be also fulfilled by the factory. So where is it now, right? Yeah, we have to look a bit closer to the factory. We just look to the tool offering and a bit to the core features. There are the pipelines who are now calling the tools. It's simplified, but that is what basically happens. Based on some conditions, the order is determined which tool first and what content has to be taken then for the next tool. That is kind of the control system for the tool side of the factory. So, and yes, of course, by process, we have certain metrics defined. Might be a requirements coverage metric, might be some coding rules violations are automatically checked by a code analysis tool. This is defined by the process, but now it is, or it shall be, part of the factory. So how is that done? First of all, yeah, the factory will not change the criteria. That is, if you assume that the process will stay the same. So how we do this? First of all, we have to see what can go wrong there. What is the downside of it? If we're ignoring the work products the projects are producing, we're just looking to the automation artifacts, the red ones. So all the scripts pipeline used by a project provided by the factory, they now, the more you have from these automation pieces, the more they override the templates and process artifacts provided by the classic process description. So you might say, not a big problem, right? We just have to keep the process description and our factory consistent, right? That shall not be so difficult. In general, that's true, but it's not that easy, as you might think. If we now look into the real projects where we have software developers applying the process templates, what they have to do, they work on the visible part. The automation pieces, they don't see them, right? They are somewhere in the factory. We have, of course, as we have it today, we have process managers who are maintaining the process description, and they are then used by those who apply. So far, so good. But who cares about these red ones? So the first thing we have to do, and which is a good rule in automotive industry, if we have a problem, we always throw a new role on it, a kind of new assignment. If that is always a smart solution, I don't know, but in this case I would say yes. We need somebody who's maintaining, like in the real factory, maintaining the machinery, which is the red part here. Someone who knows the processes and who knows what the software developer is doing. He has to bring these things together. So these three roles, of course, they have to be aligned concerning processes, because both have same requirements. That means the process requirements, and they have to be aligned so that the automation piece works accordingly what is written in the process description. Yeah, and that makes the job even a bit harder. Of course, all those requirements we have from standard, they of course impact all these three roles, right? So all these metrics have to be considered on the red pieces side, but also on the process artifacts, and even those who apply have to consider some requirements from the standard side, which are provided then by the process. So again, even more we have to work together and being aligned. That is one thing which works. Of course, that is not fault-free, right? There can also be still failures implemented in the software factory, right? People can be misaligned. What else can help here? So a second part of the solution is, still we apply as software developers. That's no change, of course. If we forget for a moment the software factory maintainer, we just look at the process manager. That one is still maintaining those visible parts of the process. And in addition to that, we have to implement in the factory a kind of data model, which is, of course, fed by standards, which turns then into these metrics, which are showing up again. These metrics are now tied to these automation pieces or artifacts, and they show more than just a value like requirements coverage is 80% or code coverage is 50% or branch coverage is 50% or whatever. They show you also the process. So these metrics have a process description in terms of what is requested and what's your actual value. So we have a living process description. At least we have pieces of it in these metrics. That has to be provided by the factory to also help the software developer to know where am I, right? What's my process? What needs to be achieved and where I am, right? And that, of course, is easier to maintain because also software developer would have a look on what is in these metrics to find potential misalignments in the process side, right? And also in assessment, that's the position where I'm often in. It's helpful. You have some insight in such complex tools. Otherwise, the people would just say, hey, we just feed in the data in the tool and we get something out and we just believe what's coming out. That is always difficult to judge about that in an assessment situation, right? So such kind of metrics giving me a feedback concerning standards and processes, of course, they help to get the inputs for an assessment, right? Yeah, you could say that is from this factory point of view a kind of dashboard, right? Software factory dashboard. Same thing here, right? Everybody can see from the distance, where are we now? How much software we have produced? What is the quality level now? And maybe the traffic light symbol saying, hey, we are on red, we are on yellow. All these things you might have seen in software development will, of course, show up here again, but as an integrated part of the software factory. And it's an integrated part of the process, not just tool functionality. View to the future, I promised a bit to talk about AI, but maybe that would be too much to talk about AI now in the detailed level. But of course, yeah, that might be a picture for the future, that we have AI agents who are using large language models. We just prompt our production plan there as a contract, and then the agent runs by its own, touching all the APIs of the factory. So it's writing requirements. Then another agent is analyzing requirements concerning violations. Then there's a review done by another agent, and then again another agent kicks in, and so on and so on. So I know that it's a visionary statement, right? But this is where we are going to if you talk about generative AI now. That is a dream we have. Maybe we will not have the full-blown thing, maybe partial AI in our factory. That might be, not everything might work, but some of these concepts might work. Today we already have code generation out of AI, so that seems to be not too far away. But if we can generate requirements out of whatever, right, customer statements, I'm not sure if that is possible, right? But okay, at least that is a vision some people work on. But yeah, certainly we are not there, that is true. So as a summary, back to the software factory, what we really see, at least on a small footprint, yeah, it comes from SDV. SDV is a holistic approach, and the software factory is just one pattern out of it. But it makes pretty much sense from the whole holistic picture to have something like a factory with all these criteria we have mentioned. Yeah, the factory essentially is a set of tools that are chained together, but not just chained by partial automation, by a software factory with all those metrics in there, with all those features and repositories, so that a lot of things can be done automatically without any manual intervention of a software developer. And that assures, of course, steady quality, right? Because we always assume software produces always the same thing, does always the same for it too, but is not behaving randomly, like human beings doing that. Yeah, and also we have seen some examples of known software quality criteria which are still there, but they are now treated in another way to avoid that they are hidden away from those who apply, from those who assess. And we talked a bit about the software factory maintainer who has now a job in addition to the classic application of processes and definition of processes. That's it in a nutshell, right? What we want to provide to you as a picture, what changes by software factory concerning software criteria, quality criteria. Certainly that maintaining thing need more skills in our companies. Typically what we see today is that software developers who are developing the code, that they are also maintaining the tools. And I think at a certain point of automation, that makes no sense anymore, right? So we have to separate these tasks to people who are capable in software development, but also they have skills in this process area. So they have to bridge the gap between the process managers in the classic way and that software developers, right? So that is certainly a skill we lack in our industry, and we need it. And that is, yeah, that's the downside of it. Just the factory without these skills would not bring that effect, that would not support the business cases as we intended. Last word to it, if you think you need help in that area supporting, we have solutions at Vector for Software Factory for the problems we have shown, so don't hesitate and come back to us. So if you have more questions now, I hope not for shoemaking, because it's not my business, but if you have more questions about how Software Factory can build up, what in between stages makes sense, what we have to consider concerning safety, security, and all these processes, I'm open for your questions now.